Hey there, science fans! Today we're diving into the fascinating world of stoichiometry. Stoichiometry is like the ultimate recipe book for chemists. Just like a recipe tells you how much of each ingredient you need to bake a cake, stoichiometry tells us how much of each chemical we need for a reaction. It's all about the relationships between reactants, which are the ingredients, and products, which are the final dish. Imagine trying to bake a cake without knowing how much flour, sugar, or eggs to use. It would be a disaster, right? Similarly, in chemistry, we need to know the exact amounts of reactants to get the desired products. Stoichiometry is crucial in various fields. Chemists use it to develop new materials, synthesize medicines, and analyze the composition of substances. Get ready to unlock the secrets of chemical reactions. Before we can cook up some chemical reactions, we need to understand the language of molecules' chemical formulas. These formulas are like name tags for chemical compounds, telling us what elements they contain and in what proportions. Let's start with empirical formulas. They show the simplest whole number ratio of atoms in a compound. Think of it like finding the most basic recipe for a cake. You might need 2 cups of flour for every 1 cup of sugar. The empirical formula would be like saying 2 flour to 1 sugar. Next up, we have molecular formulas. These guys give us the actual number of atoms of each element in a molecule. This is like having the complete recipe for a cake, including all the details. Finally, we have structural formulas. These are the architects of the molecule world. They show us how atoms are arranged and connected within a molecule. Understanding these different types of formulas is essential for deciphering the language of chemistry. Catalysts are like the cheerleaders of the chemical world. They make reactions happen faster without being consumed in the process. Think of them as facilitators, helping reactants get together and do their thing. How do they do it? Catalysts provide an alternative pathway for the reaction to occur, one with lower activation energy. Activation energy is like a hurdle that reactants need to clear to form products. Catalysts lower this hurdle, making it easier for the reaction to happen. Catalysts are essential in many industrial processes, like the production of fertilizers, plastics, and fuels. They help us save energy and reduce waste by making reactions more efficient. Let's put our stoichiometry skills to the test with a classic chemistry experiment, the decomposition of potassium chlorate. In this experiment, we heat solid potassium chlorate, a white powder, in the presence of a catalyst, usually manganese dioxide. What happens next? The potassium chlorate breaks down, releasing oxygen gas and leaving behind solid potassium chloride. It's like watching a magic trick. This reaction is a great example of how stoichiometry allows us to predict the amount of products formed from a given amount of reactants. By carefully measuring the mass of potassium chlorate before and after heating, we can determine the amount of oxygen gas produced. Now let's use the data from our potassium chlorate decomposition experiment to determine the empirical formula of potassium chlorate. Remember, the empirical formula gives us the simplest whole number ratio of atoms in a compound. First, we need to determine the mass of oxygen released during the reaction. This can be done by subtracting the mass of the residue, which is potassium chloride, from the initial mass of potassium chlorate. Next, we convert the masses of potassium chloride and oxygen to moles using their respective molar masses. A mole is just a unit of measurement for chemical substances, like a dozen eggs. Finally, we divide the number of moles of each element by the smallest number of moles to get the mole ratio. This ratio gives us the subscripts for the empirical formula. For example, if we find that the mole ratio of potassium to chlorine to oxygen is 1 to 1 to 3, then the empirical formula of potassium chlorate is KClO3. Stoichiometry can also be used to determine the purity of a substance. Let's say we have a mixture of potassium chlorate and potassium chloride, and we want to know how much potassium chlorate is present. We can do this by heating the mixture and measuring the amount of oxygen gas released. Since only potassium chlorate decomposes to produce oxygen, the amount of oxygen released is directly proportional to the amount of potassium chlorate in the mixture. By using stoichiometry and the balanced chemical equation for the decomposition of potassium chlorate, we can calculate the mass of potassium chlorate that corresponds to the measured volume of oxygen gas. This allows us to determine the percentage of potassium chlorate in the original mixture. This method of analysis has practical applications in various fields, such as quality control in chemical manufacturing and environmental monitoring. Chemical reactions are like stories, and chemical equations are the way we write them down. These equations use symbols and formulas to represent the reactants and products of a chemical reaction. A balanced chemical equation shows the same number of atoms of each element on both sides of the equation, following the law of conservation of mass. For example, the balanced chemical equation for the decomposition of potassium chlorate is 2KClO3 solid yields 2KCl solid plus 3O2 gas. This equation tells us that 2 moles of solid potassium chlorate decompose to produce 2 moles of solid potassium chloride and 3 moles of oxygen gas. Learning to write and balance chemical equations is crucial for understanding and predicting chemical reactions. Learning chemistry in a new language can be challenging, but don't worry. Here are a few tips to help you succeed. First, start with the basics. Make sure you understand the fundamental concepts such as atoms, molecules, and chemical reactions. Next, break down complex words. Chemistry terms can be long and intimidating, so break them down into smaller parts and try to understand their meanings. Also, use flashcards. Write down key terms and definitions on flashcards and review them regularly. Practice, practice, practice. The more you practice reading, writing, and speaking chemistry in English, the more comfortable you will become. And don't be afraid to ask for help. If you're struggling with a concept or term, don't hesitate to ask your teacher or a classmate for help. Remember, learning a new language takes time and effort, so be patient with yourself and celebrate your progress along the way. Congratulations, science explorers! You've now journeyed into the world of stoichiometry, chemical formulas, and catalysts. Remember, stoichiometry is all about the relationships between reactants and products in chemical reactions. We've learned how to use stoichiometry to determine the empirical formula of a compound, calculate the percentage of a substance in a mixture, and understand the role of catalysts in speeding up chemical reactions. By mastering these concepts, you're well on your way to unlocking the secrets of chemistry and achieving success in your studies. Keep those chemical reactions balanced and never stop exploring the wonders of science. If you have any comment or inquiry, please write it in the comments, as your opinion is important to us so that we can continue and develop. And do not forget to support us with a like and share the video with your colleagues so that the benefit is widespread.